For our next two examples, we're going to use the shifting rule with the exponential function. And so the main way to do these is to really think about what original function f of t has a transform that is being shifted. And so for this first example, this 3 over s minus 4 cubed, that looks like the power rule, which looks like a t squared Laplace transform. But again, it's got a s minus 4 in place of the s. So the idea would be to think about that as our inverse transform, but you'll notice that we have a 3 up there instead of having a 2 up there. So we're going to, once again, factor out that 3, or kind of write it off to the side. And we have s minus 4 cubed. Again, that 2 will be absorbed in the inverse transform. So we're going to have a 3 as our coefficient. Now our exponential is going to be e to the 4t because c is equal to 4 in this case. So it's going to be an e to the 4t. And again, our function f of t is t squared since we've got 2 over s with something cubed. For our next example, you will notice that the s's do not match. And so because of that, we have to make sure that they do match to do our transform. So the clever way of handling this is to actually introduce what's missing in the problem. So we're going to take that s that's in our numerator, and we're going to subtract 2 and add 2 so that it matches the denominator of the inverse. So we're going to have the inverse of the original s, and now we'll kind of change colors to show this with a minus 2 and a plus 2, and then we have our original plus 1 in our numerator, and again, this is over s minus 2 squared. We are now going to split apart this fraction as the inverse of an s minus 2 over s minus 2 squared. And then if we take that 2 and that 1 together, we have 3 over s minus 2 squared. From here, we can now take and simplify this down. So the first one, simplifying, we just get 1 over s minus 2. And again, by linearity, that's 3 times the inverse of 1 over s minus 2 squared. For the first one, you will notice that that's going to just be our exponential function, e to the t. For the second one, you'll notice that it's going to be the exponential shifting. Actually, it's e to the 2t. My apologies there. For the next one, we're going to have our coefficient of 3, and that's going to be the shifting, making an e to the 2t. And then the inverse Laplace transform of 1 over s squared is just simply a t. And of course, this can be written in a factored form as 1 plus 3t as an e to the 2t. And again, if you're ever uncertain about your answers to these problems, you're always welcome to go in and take the inverse Laplace transform and verify that it simplifies down to the original problem.